Hi, this is Kenny Lee, and let's talk a little bit about momentum. We've been talking about kinematics, where we talk about velocities and accelerations, and we talked about Newton's laws, where we discuss things in forces. And we may even talked about energy. But momentum is kind of a topic that bridges the difference between forces and kinematics. Matter of fact, Newton kind of wrote his laws more or less in terms of momentum rather than acceleration. And what momentum is the product of an object's mass and velocity. And so it's equal to mass times velocity. So momentum is a vector, and we need a symbol for momentum. And it turns out we can't use m because m's only used for mass. And so what we ended up using was a lowercase p. The reason goes back to Galileo, where he talked about persistence, and we get the lowercase p from that, from the Latin for that things continue on. The unit is kind of weird, where mass is in kilograms, velocity is in meters per second, so our unit is kilogram meters per second. And we didn't come up with a clever shortcut like we did for newtons and joules and other things. We just left it kilogram meters per second. I guess we were too lazy to come up with something new. But the reason why momentum is more of a basic description of motion is because of this. If we take something like an atom that is very, very small, not much mass, and let's say it's traveling at a huge amount of speed, like 1,000 meters per second, and it hits you, well, you wouldn't really even notice, because it wouldn't do anything, because even though it has such a high speed, it has such a low mass that it's not going to really do anything. So just speed by itself won't tell you what it will do to you. A wrecking ball is very massive, but its speed may be very, very low, like 10 meters per second. And so you think 10 meters per second, that's not very fast. Well, it technically is, but as far as comparison, it looks kind of slow. And you think that wouldn't do much, but because of the mass of the wrecking ball itself, it can destroy buildings. So it's that combination of mass and velocity that gives you a more complete description of motion. And that's what momentum is. So let's talk about a couple of really basic problems with momentum. The most basic problem we can get is this one right here. What is the momentum of a 500 kilogram cart traveling at 12 meters per second? So we've got a cart that has a mass of 500 kilograms, and it's traveling at 12 meters per second. Well, momentum is mass times velocity. Mass was 500, velocity is 12, and so we just simply multiply those together, and we get 6,000 kilogram meters per second is our momentum. Now, I do want to point out one thing. We can have a slightly different look for that unit. Sometimes we'll write it as Newton seconds. So you may see it as that in some places. Though for most of the time, I'm going to write it as kilogram meters per second. Let's do a couple more. We have an athlete running, and they have a momentum of 210 kilogram meters per second, and her mass is 50 kilograms. We want to figure out her velocity. Well, again, momentum is mass times velocity. We've got a mass of 50 kilograms and a momentum of 210 kilogram meters per second. So we plug those in. 210 equals 50v. So I take 210 divided by 50, and we get a velocity of 4.2 meters per second. These basic momentum problems are really quite easy. They get a little bit more interesting when we talk about conservation momentum and impulse later on. One last example. So this one, we got a little toy train that has a momentum of 0.72 kilogram meters per second when it's going 0.6 meters per second. We want to know its mass. Well, again, we know the momentum is 0.72 kilogram meters per second, and we've got a velocity of 0.6 meters per second. So momentum is mass times velocity. Momentum is 0.72. Velocity, we don't know mass, but we do know the velocity is 0.6. And so 0.72 divided by 0.6 gives us a mass of 1.2 kilograms. There's your basic description of momentum and problems that go along with it. Tune in again when we talk about momentum and impulse, as well as conservation of momentum. Thank you. Have a good day.